Focus. Alright, guys, we'll be starting shortly. Next. Echo, people say.
Yeah,
Okay. Testing. Testing. Testing.
this machine is silent. Speaker must off. Station.
Testing.
Yeah.
Hello, testing. Okay, no problem. Guys, we'll be starting in 5 minutes shortly. Sorry for all the technical issues. Good morning, everyone. Welcome to our week 2 of our GenAI study jam. And thank you for everyone who's joining physical and also online as well. This event was hosted by Sunway Tech Club and also in collaboration with the Artificial Intelligence and Machine Learning Malaysia. Before we start, I'd like to give a warm welcome to our speaker for today, Dr. Azam, an associate professor at the Department of Data Science and Artificial Intelligence, and he's also a lecturer in our School of Computing and Artificial Intelligence at Sunway University as well. Now I'll hand it over to Dr. Azam to begin the session also.
So I use my own mic.
Yeah, this is mic. It's connected to that mic. Yeah, so it's pick up from that. Yeah, should be okay.
Right. Right. Everybody can hear me? Is sound okay? Right. So let me introduce myself first. My name is Dr. Azam Idris. I'm originally in the field of aerospace engineering. I was trained as a rocket scientist, working with hypersonic flow. And in 2017, I changed my focus to AI. Previously, I was in the Defense University, and after that, I worked as an assistant professor in government. And now I'm here in the Department of Data Science and AI. I have a certified IBM AI engineering professional, and I'm also a chartered engineer, chartered IT professional, and also a chartered manager. I work closely with a lot of startups, a lot of AI startups. I have my own startup as well, working with drug design, AI for drug design.
Teams is sharing it, right?
Just continue. Right. So for today's session, our goal is to demystify how modern AI can remember large knowledge thoughts to students, update and produce more accurate answers by using embeddings, the database, and large language model. Right. So when Prof Lau invited me for this topic 2 weeks ago, I didn't realize there's already material for this in Kaggle. So I made my own, totally my own. So you can run the Kaggle one, course, and I also included my own. We have 3 examples. So I will give the link later. The link is included in the slide. The slide I will share with the organizer that will also share with all of you. So I've noticed in the Kaggle example, they use Google Gemini as the LLM and a lot of Google related packages and frameworks. Mine will use OpenAI and also LangChain, Hugging Face. But at the end of the day, you will learn right. No doubt about it. You will learn retrieval augmented generation. You will learn about the workflow and relevant concepts that you need to understand to implement right with your own project. But the tools that we will use quite different. So hopefully this will be like an additional for you because the Kaggle one, the code is already there. You can just run it and then you can learn from that. But mine will a little bit different. But also we will focus on the similar objective. Okay. Right. So hopefully everybody can see my slide. Okay. On the online session. Okay. So I've divided this into 2 parts. The first part, the simple rack setup, and the second part will be more complex. there will be 3 examples. One is the simplest one, and 2 will be slightly more complex, but not too complex, because obviously we cannot learn everything in one day. Right. Usually for this kind of training, I've given many trainings, AI trainings for corporate and industry, because I'm a HRDC certified trainer. And usually for this kind of training, will take 1 day or 2 days. And usually they will charge 1,000 per head per day. So you're getting this for free.
Can reshare because some just joined.
Okay, share what?
Can need to reshare because some just joined the session.
Share the PowerPoint.
Your slide.
If somebody join late, they can see the slide.
Yeah.
Okay. Hopefully everybody can see now the slide. Yeah. Okay, so why RAG? Obviously, now there's no shortage of LLM. So LLM is, to recap, LLM is large language model. So you have GPT, Gemini, Cloud, Anthropic Cloud, you have DeepSeek, and you have all the open source like Llama, Falcon, Alpaca, there's a lot. Even the, the Malaysian one, Malam, Mallen, Malam, the Malaysian one. So yeah, there's no shortage of LLM, but LLM, people found out recently, this in publication 2024 and this year, people found out actually the more powerful the LLM, the more it will hallucinate. Used to be the hallucination was for the previous older generation of LLM. So hallucination, what is hallucination? Hallucination is like when you ask something, especially even in the past or known facts that the LLM was not aware of, probably was not trained on that topic, you will give out some bullshit answer. You will make up stuff. Okay, so that is hallucination. And that's one problem. And if they found out recently, the more powerful the LLM will be, the more confidence it gets in terms of making up stuff. So people are trying to how to solve this. Obviously, they think that you add more data, basically adding more documents or more text for them to learn. And as apparently that's not enough. So they say RAG is one of the few methods that can control LLM so that it will give out relevant response to any prompts or queries. That's one problem. Another problem is that LLM, they have to cut off time. Cut off time in terms of they will be trained up to a certain point. So the previous generation of ChatGPT, the one that they first introduced, the cutoff point was 2021. Now I think they're up to date 2023, 2024. I'm not sure. So they need to always update with new information. Update meaning they need to retrain. And retraining takes a lot of time and computing power. So obviously that's depending on the situation, that's not good enough because sometimes you need to update your whole LLM system quickly. Retraining will take a lot of time and take a lot of GPUs and etc. So that's why we are interested in this topic. Right.
Share the just the window. You can share stuff.
Okay.
Right now you're sharing on the side.
Okay, this PowerPoint line. So let's see.
Share the
The
window.
windows
Yeah.
on the
Share the
minus already. Right. Hopefully everybody can see the slide now. Can turn off the speaker. Yeah, so we talk about limitation of LLM. So how LLM works is by using transformer architecture. Okay.
Program sharing. User.
Okay. Ah. Right. So there's echo. Instead of mute, okay. Sorry. Today's topic very advanced. We talk about AI, but we cannot solve the problem of this echo. Okay. Okay. Better. Right. Okay. So for LLM, they will take large tag and then or even whatever text, large or small prompts, they will tokenize and then they will insert into context windows. To solve the limitation for knowledge cutoff and hallucination, I think the hallucination and I think it's the major problem is the hallucination that we want to solve with RAG. And the other one is sometimes when you ask very recent information to LLM, and then it will respond with, I don't know, I have no information. And both are equally frustrating, hallucination and also when it says, I don't know. Okay? So it works like this. So when a user give a query, for example, in this diagram here, how do you evaluate the fact that this OpenAI CEO behaves this way and I got this maze? This is a very recent fact. And after that, the question will be tokenized and then use chunk to put into the embeddings. The embeddings they will search from the what they have been stored before. So maybe they have already relevant documents that they already trained on the rack. Okay, so maybe news, for example, news they have trained on the rack system. So the rack system, in the vector database, will look for the relevant news or relevant information that is related to that query, and then it will give out this document to combine it with the prompt. So the prompt, instead of just the simple query, the prompt now will be, for example, how do you evaluate the fact that OpenAI CEO, blah, 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 and base your answer using these documents. So rack system is like you're building a middleman to the to interact with the LLM. Okay, imagine it like this: LLM is a general people, layperson. It's not specialized on that topic, even though it's very knowledgeable. Okay, you have this illusion that maybe he's a very wise person, but you have to remember he's a layman. So when you talk to a layman, maybe with high IQ, so you ask for his opinion about something he doesn't know. So he will either make up stuff or he will say, I don't know. So you then take some relevant document and say, okay, this is document that I want you to look at. Okay. And then this is the question that I want you to give the answer to. Okay. So this middleman will interact with the LLM. So this will be useful in a lot of situations. Okay, for example, uh, for example, you want to build a rack system to understand Malaysian law. So a lot of Malaysian law are stored in the law journal. Okay, and obviously, the law journals, some are not in digital form. Most of it may be in the written form. So ChatGPT, even though he has stolen a lot of data set for it to learn, maybe he's never encountered the law document. So he never read the law document, a lot of law journals. So instead of taking ChatGPT and retrain them for the law document, okay, you build a rack system that understand the law document, the law journals, and then this rack system will interact with ChatGPT or Gemini or DeepSeek or whatever. Okay, this is one example of how to use this. So the anatomy of rack pipeline is first, you have two parts. The parts that you do it before you deploy your rack system, and the second part is the part that are active during the deployment when you interact with the user. So the first part, the ingestion part, is where you basically train your rack system. You split raw documents into chunks. Chunks usually about 500 token each, and you create embeddings. Embeddings are basically vector. So you have very high dimension of vectors. Vector, like if you learn in school, probably you know three-dimensional vector. Okay, in a X, Y, Z plane. Okay, that's three-dimensional. But embeddings usually have like 500 dimension, which you cannot imagine. But basically, in the vector, you have 500 elements in that vector. Okay, so you have a special algorithm to take tokens or words or chunks of tag and to change it into embeddings. And then you store it in a vector database. Okay, that is before you deploy your rack system. So after you deploy your rack system and then interact with the user, so users start asking question. So the retrieval part will then take the user query and then split into chunks as well or tokens, and will look at keywords, some keywords within that query to look for similarities with the stored embeddings. Okay, if you have exact words, easy lah. If you don't have exact words, probably will look at the similar. So for example, if your embedding is about cat and then the query is about kittens, so they will find it very similar. So it will retrieve the stored chunks and then include that in the new prompt. So you have a new prompt that comes from this augmented generation. So the generation part is actually generating new prompts. Okay. So it will concatenate retrieve chunks based on user question and then include this into LLM prompt and give it to the your chosen LLM, ChatGPT, DeepSeek, or whatever. And then LLM will generate answer based on that context, based on the user query and also the additional documents that come from the vector database. Right, and then after that, you have the optional, you can do re-ranking, store, retrieve chunks for relevance, and custom prompt template to control generation tool. This is how you customize afterwards. So the first part is this one, ingestion and indexing. So you load all your document that you want your rack system to learn, and then you split into chunks, and then you embed. So embed will change into vectors, and then you store them in vector database. That is the before deployment of your rack system, and retrieval and prompt generation is during the deployment, after you deploy and during the user query. So what are embeddings? Embeddings are basically vectors, like you see there. Okay, so embeddings are basically vectors. Numeric vector representation of text and images. You use this semantic proximity, similar meaning will have similar vectors, and common embedding models, for example, like this, embeddings, text embedding ADA 002, OpenAI, or Hugging Face sentence transformer. The second one is open source, and you don't need an API to use. The first one, you need an API. Okay, strictly speaking, this embedding model is an LLM. In itself, an LLM. Understand? So basically, you are building a smaller LLM in the rack system to interact with the larger LLM. Okay, this is itself a language model, but not that big lah. That's why they call it mini LM, mini language model. And you have a lot. That's too much to choose, and will give you confusion in terms of choosing it. So I will list some later. I will show the ones that I use myself and the one that I recommend. But if you prefer, you can also use the one from OpenAI. But this will require API, meaning you need to pay. You need to have the API key. So these embeddings will convert each document or chunk into 500 or 1000 something dimensional vector. Okay, and this is how the embeddings are visualized. So for example, you have the word cat there. It will give like, this is to make it simpler, this is 7-dimensional vectors, meaning you have 7 numbers there, 7 elements, and in one vector. Okay, that is for cat, kitten, dog, and houses. And then you store them. Obviously, you store them in a 7-dimensional space. But this one, basically, you cut the space until you see only a plane of it. So it becomes 2D space. Okay, and in the 2D space, you can see cat and kitten are very closely placed together. Dog, quite close as well to cat and kitten, but houses are far away from them. Why? Because cat and kitten are basically the same thing, cat and kitten. But dog and cat are usually related because they are both pet. And this group of pet have small commonality with houses. So houses quite far away. Just like another example here, man, woman, and king and queen. So man and woman related, both are human. King and queen also related, both are like the royalties, the position in the country. But man and king are closely related, more closer in terms of distance, rather than in comparison to a woman and king, because king are usually men and queen are usually woman. Okay. So what is a chunk? So chunk is a large group of text. Okay. So basically you have, for example, article. Article, maybe you have 10 pages of article. So obviously you're not going to process all of them in one piece. You will cut them up, slice them up into contiguous segment of text. Usually in terms of 500 words for each chunk. Usually. But LLM doesn't work with word. LLM works with token. So token is actually the atomic unit for text. So token could mean, depending on the language model, token could mean word itself or part of words. Or in Malay, we call it suku kata lah. Okay. I don't know the words in subwords. Or sometimes even token could mean characters. Okay. But usually subword. But depending on the language model, sometimes they mean words. Okay. So chunk, probably 1,000 characters or per chunk, or 1,000 token, and tokens, 500 tokens per chunk. So why tokens matter? Each language model usually have a maximum context window, either in terms of tokens or characters. So for ChatGPT 3.5, you have 4,000 tokens, and GPT-4 you can give in terms of prompts 32,000 tokens. If your chunk exceeds that, the model will truncate or drop parts of it. Okay. So meaning you can give very long prompts to the language model. So choosing the chunk size and overlap, the chunk size usually you set between 500 and 1,000, and the overlap is between 20% or 10%. What is overlap? Overlap because you split into chunks, and chunks will have some overlap. Chunk number 1 and chunk number 2 will have maybe 20% overlap. Okay, right. And the second issue is, why do we need vector database? Right. So when you convert chunks into vectors, it need to be stored somewhere, not just the vectors, but the metadata. Imagine the vectors as a key, okay, like password. So the password must point out to something. You open up something, which is the text, the chunks itself. So you have two things that you need to store as pairs, the vectors and also the chunks. Okay. Now you have a lot of things to store now because you have a lot of chunks and also a lot of the vectors that point out to which chunk. You need to store them in vector database. Okay. So vector database basically it works like any SQL database. Usually you have this you can do this create, insert, read, update, and delete, and you must have a metadata handling. You can do text and timestamp. You can do high dimensional indexing, and some of the popular vector database, Pinephone, Chroma, Qdren, Vivian, Milverse. But the one I will show will use this one, Facebook AI Similarity Search. This is local. It will start locally. Okay, it will start locally during the session, during your when you're running the Python notebook. It will be stored in memory. All others will require API, meaning you need to pay. Okay. So these are some of the example of vector database. So on the top left there, dedicated vector database. This one is usually SQL or other type of data database that can also handle vector search. And you have the open source and also commercial version. Okay. So Chroma, Milverse, even though they're open source and Qdren open source, but when you want to run it, you can either store Chroma in your own server that will be free, or you can use their server, so that will require API. Right. So right use cases and benefits. Usually now a lot of people are using it for specialized or dedicated question and answering system for enterprise. So imagine you have a car company. Okay, you make EVs. Okay, for each car you have this thick of user guide. Okay, and then people will ask question through the chat. Okay, I have this problem. Happens like this. The blinker went out on this symbol when is showing. What should I do? If you ask straight away into ChatGPT or DeepSeek, obviously it's not familiar with your car brand, and also the user guide. So you load all your user guide into a RAG system. Okay, it will understand the user guide, stored into vector database, and then whenever user query, it will look for the relevant chunks from that user guide. Okay, it will take pages of that user guide and also the user query, and then later will fit into your chosen language model, like ChatGPT, DeepSeek, whatever. So that then the language model will then answer. So that is one immediate use cases for RAG. A lot of companies doing this. So customer support, and the one that I told you before, the legal and medical application, there's a lot of potential of it. So imagine an app that can act as a free lawyer for you. So if you have a legal question, okay, usually you think, oh, I need to see a lawyer and ask them, and probably he would charge me for consultation fee. But imagine an app when you ask question, and it will point out the relevant case that have done before. This company versus this company, what the outcomes, what the precedent of the previous judgment. Obviously, you need to fit all the documents, and this is, and I think, a very huge potential if you want to do a startup here based on that legal. And if you do it, please include me. I want only 5%. Okay. Also, medical application. You have an app, doctor. Doctor, obviously you need to see a doctor lah, kan? But before that, you can ask question based on certain condition, personalized assistant, and a lot of things. Okay, for myself, I use Stripe for what? I use Stripe for recommendation system. I have a startup that works on drug design. So we create health product based on chemical information or based on natural derived chemical compounds. So we understand the chemical compound from the documents that have already been published. We fed into the right system. So whenever people ask, okay, I have this problem. Okay, and for this problem, what chemical compounds or drugs or natural derived chemical compound that can help with this problem? Fit into the system, it will give out the answer. If you straight away ask the LLM like ChatGPT, DeepSeek, they will hallucinate. They don't know. Okay. So let's first, for this, let's do our first rap model here. We will take the small text, the three text there, three sentences for embedding in that thing. First text is Mars is the fourth planet from the sun, and Venus is second planet, Jupiter is largest planet. And we use sentence transformer as the embedding model. I use this because it's free, so we don't need API for that. It will be stored locally using FAIS, Facebook AI similarity search. It will store in memory, not even on the disk, on memory. And it will retrieve and generate an augmented prompt based on a simple user query. So the user query will be which planet is called the red planet. So based on the text there, it will take two chunks. First chunk, it will take Mars is the first planet and often called the red planet because in the query, it says red planet, it will take the first chunk there. And also it will take the third text as the second chunk because it has the word red there. Okay, and we'll see that during running of this notebook. Right, I will give the link through the chat. So if you want to run it, please click on the link. Okay. Okay, can you open the link? Please respond if you have any problem, if you cannot open it. Okay, they can open. Right. So this the Python notebook. It's very small, very simple. So we use files using just CPU, not GPU. We use sentence transformer. Sentence transformer, I want to remind you again, sentence transformer is like a mini language model. So in itself, it's a language model, not as big as a ChatGPT or whatever, but in itself, it's a language model, but it's mini. And we use the old version of OpenAI because some of it require the old version. And then we import OS, 5S, NumPy, Sentence Transformer, and OpenAI. On the second part here, we will require API key. Okay, in a public notebook like this, never put your API key straight away. So this one, when you run this, it will pop up and like a prompt, please enter your API key. Okay, and I include here the sample documents. And part number 4 will generate embeddings using sentence transformer, mini LM, and then it will be stored in the corpus embeddings. We convert the corpus embedding to float 32 to store into the Facebook AI similarity search. And then we build the 5S index. Okay. Again, I want to remind this is everything in memory. So meaning if you have very large documents, you need to have very large RAM. Okay. Why doesn't it store in this? If you start in this, it will become very slow for indexing. So usually when you run this, it will be stored with RAM. There are some hybrid approach in indexing. There's some in disk and some in RAM. But Faiz is using RAM. Okay, and then we define a function to retrieve top k chunks. Okay, so basically we say top 2 chunks. Obviously, we cannot say 3 chunks because we only have 3 tags. Okay, and then we put in the query which planet is called the red planet, and it will retrieve the chunks, and it will give out this one, the output. Mars is the first planet from the sun. It's often called the red planet. That is the first chunk. And Jupiter is the largest planet and has a famous storm called the Great Red Spot. That's the second chunk. But this itself is not the output yet. The output is when you feed your chunks with your query into a new generated prompt, into an augmented prompt. So we use GPT 3.5 Turbo. We create a new prompt by using this. You have full assistant, and these are the chunks, and give response to this query. Okay, which planet is called the red planet? So we set the maximum token as 100 and temperature 0.2. Okay, what is temperature? Temperature, if you put small value of temperature, will give out more grounded answer based on the chunk. If you put out a very high value of temperature, usually between 0 and 1, it will hallucinate more for the higher value of temperature, meaning that it will still take chunks, but it will come up with its own, imagined answer. So if you want a very grounded response, you put low value of temperature. And then it will put out the AI answer. So AI answer is Mars is often called the red planet. Okay. Right. Hopefully you can run the code in Colab. Obviously you need API key because I use OpenAI GPT 3.5. This one. Okay. Right. Any question for the first part here? Any question?
A few questions in Q&A.
All right, let me open that one.
Sure. One I can read out. So
Right.
yeah, a few.
Right. Okay. First question. Do we need to perform some sort of tuning on embedding components in order to get accurate chunks? No. Yes and no, actually. You can, but it depends on the embeddings model that you use. If you use an API, embedding models API, like OpenAI, usually you cannot control much because it's theirs. It's not run locally, it's run on their server. If you use your own, like sentence transformer for your embeddings model, maybe, yes. But again, it depends on how much you understand the model. Okay. A lot of things in AI, when I give training to corporate industry, usually I would say live by default. Why? Because you will spend too much time selecting the correct setting. Okay. It depends on whether you want to get the answer quickly or you have a lot of time to play around. If you have a lot of time to play around, you still need to read. Need to read on the relevant concept that is used by that particular embeddings model, language model, to know how to tweak it. So different language model have different option. So in AI, we call this hyperparameter tuning. Okay, and this hyperparameter tuning differs with different language model. Right, should the same, right, where's the second question? Okay. Most of the time listening top K. So are these top P, temperature, etc. the same as top K? Which to choose to use and how to set the value? Okay, top K is different from temperature and top P. Depending on the model, some you don't need to put top P. Usually you need to put only K and also temperature. Like I said before, temperature, low temperature, grounded response, high temperature, more hallucination. So imagine like high temperature is like somebody having a fever. It will talk like, talk bullshit sometimes because they're not grounded. Okay. Top K meaning how many chunks, top chunks that you want to see. Okay, that itself sometimes you don't have to print. I mean, you only select top 3, top 5 maybe, but it depends on your context window. If your chunks is big, each chunk is big, and then you select top 5, and then you fit all top 5 into your LM, and your LM has small context window. It cannot take everything. It will concatenate. It will truncate. Okay, so usually top 3. Could this chunk be the same as sentence tokenization and given ID that's stored in vector DB? Okay. Chunks and tokenization, basically chunks and token are related. Okay. 500 token, usually one chunk. Okay. Okay, Qdrun can use locally using Docker. Yes, okay, because they're open source. So that's why I said for the open source one, if you want to run on their server, you will require API. If you run it on using Docker locally or on your server, you don't need because they're open source, like from Qdrun or whatever. Okay. Since LLM work best with tests, what will embedding will do with the diagram or charts inside the documents or PDF? Is RAG method able to provide the details of the diagram or charts, or this diagram and charts will be ignored by embeddings? Right. Okay. Now this is a very good question because a lot of text doesn't contain only text. Sometimes it contains, not sometimes, a lot of the time text will contain pictures, diagram, graph. Okay. Strictly speaking, most LLM cannot work with images. The one that I showed you, like sentence transformer, even the Open API, I think the Open API, the embedding that they use, that one is not for multimodal. Multimodal meaning you can insert text and also images as well. So you need to select the suitable embeddings that can handle multimodal. Remember the first version of ChatGPT, you can only give text, you cannot understand images. Okay, like that. So because this is mini LM, not the large language model, it's mini LM. Usually they can only handle text. Okay. But I know OpenAI have the new version for embeddings. They have multimodal embeddings. But multimodal embedding, I think is still experimental right now. Right. Is OpenAI 3.5 free? No, they are not. OpenAI is never free. OpenAI is not open source. Okay, so whenever you use OpenAI, or even Gemini, Google Gemini, even DeepSeek, they say is open source, but when you run on their server, it will require API key because they will incur costs to run the server. You can take DeepSeek to run on your laptop, can, or you can use Llama. Llama is the now considered ancient lah, obsolete, not obsolete but ancient lah, because it was released in 2017, I think. It was released as open source. Facebook Llama. I use that one to create my own custom language model to understand chemistry. Okay. If don't have OpenAI API key, then cannot run at all. Yes. Okay, what to do? Simple. Buy API key lah. $10 only. The minimum you can spend $10. And with that $10, I mean, if you only run prototype, like this example exercise, you know how much you spend? 0.03 cent dollar. US dollar, 0.03. So if you run my code here 100 times, it will not even reach $1. Okay, so I put in a simple $10. It's still there, like few years already. Okay, because for my own startup, I don't use this. I use Llama. I write on my own server. This is just for demonstration. Right, 0 to temperature is the sweet number for rack. It depends. It depends on your application. Okay, so this one you can play around to see the response. Whether this response is the kind of response that you want, or you want it to have more elaborate answer, or more factual answer, or more hallucination. How do we ensure RAG will retrieve information from our embeddings compared to the original information? This will be included, they will be set up during your prompt generation. If you notice in my code there, there's I think code number 7 or code number 8. Number 8, I think, the block of code number 8. Based on this chunks, please give response. So the language model will then understand I can only give response based on this chunk, not hallucinate. Okay, not retrieving information from the source. If not, then probably we'll have to change to use Gemini code instead. Yeah, you can run the Gemini code in Kaggle, no problem. Gemini, I don't know whether they give out free API for trial, maybe. I haven't used Gemini. I only use OpenAI usually for API. What model is best to use for embedding? I'm using Olama. It depends on the situation. Okay, it depends whether you want it locally, you want to run it free or using API locally on the server. How do I determine the optimal chunk size or token length when creating embeddings? The chunk size usually between like in my slide, I say between 500 to 1000. Okay, the optimal size 500 to 1000. Any. A lot of thing in AI actually, there's no like very hard rule. A lot of it is actually, try and error. There's a lot of it. Yeah. When I teach, for example, neural networks, people will ask, how many layers do we need in a neural network? And each layer, how many nodes we need for each layer? There's no theory that says you need this much nodes or this much layer. There's no. You can try and error, play around. Right. This temperature is determined how creative the answer will be. I guess you have to test the value. Okay. Need to test run a few times to test the temperature. Yes. Okay. What do you mean by the word creativity? Yeah. Hallucination. It will hallucinate. It will make up stuff. Very high temperature will make up stuff. Basically, it's like you are using straight away the language model without any rack system. It will hallucinate lah. Maybe, hopefully, it will not hallucinate because it's already informed about the topic that you ask. Maybe, but usually not. Especially for a specialized, like in a company, you fit in the user guide. You never read your user guide before, so it will make up stuff. Okay, so like Malaysian legal journal, you never read the Malaysian legal journal, so it will make up stuff. Okay. Right. If you have a document table, sometimes track might not be the best because data is structured. You can implement a tool calling structure where you get the model to create an SQL query to obtain the relevant information and then use the obtain from the query and append to prompt your answer question. Yes. Vector, like I said, is suitable for text. If you have structured data, like a document table, track might not be the best. But there are alternatives for vector embeddings. You can use knowledge graph. Okay, you can embed using graph rather than vectors. But that's a totally different topic from today. Right. Shall I continue or you want a 5-minute break? So continue? Want toilet break? So, yeah. Huh? 5-minute breaks. Okay. 5-minute breaks, everybody. Right, we can continue. I've seen some more questions, so maybe I can read the question. Right. I have a spreadsheet with millions of cells data. Does this demo work for such big data? No. Today's demo is quite simple or not very advanced. But for spreadsheet, millions of cells data, mm, if you have a spreadsheet, I'm not too sure whether RAG will be the best for you. Because RAG usually deals a lot of text, but if you have millions of cells and within that cells a lot of numbers, I'm not too sure whether RAG will be suitable for you. Okay. Okay. When a model generates word one by one, a temperature will give more chance to strange, unique, not suitable words. So basically hallucination lah. Hallucination they make up stuff. Okay? Or they give answer not based on your reference. Because when you augmented your prompt, okay, you augment your prompt. So augment prompt basically you say, okay, this is the user query. Answer this query based on this reference, this chunk of text. If you have a higher temperature, probably they will deviate a lot from the relevant text. Okay. So let's continue with the slide. I hope everybody can still see the slide. Okay. So part 2, customized rack setup. So here we will start to discuss more on related tools and libraries. For example, there's a lot and a lot and a lot. I always say there's a lot because there's too much to choose from, and it give you up, cause you confusion in terms of which one to choose. So for OpenAI API, there's a lot of text embeddings available in OpenAI. I think now even they include multimodal that can also handle text and image. For the local one, if you want to run on your own laptop, your own server, you have the sentence transformer, you have this one, all mini paraphrase, you have the multilingual LM. There's a lot more. And vector database, the one that I showed just now, we use FAIS. You have Chroma, Pinecone, Qdren. And now I also want to introduce RAG frameworks. You have this LangChain. Usually people in doing RAG, probably they use LangChain. You also have Haystack, Llama Index, and of course LLM providers. There's no shortage of large language model now, like ChatGPT, of course. Google. I think Google have several, not just Gemini. DeepSeek. You have Anthropic Cloud. If you want to run locally, you have Llama, Llama 2, Falcon, Alpaca, a lot. Right. So for embedding generators, this is some of the most popular one lah. Okay. You will see this a lot. Hugging Face embeddings. Okay. Hugging Face. I don't know how to classify Hugging Face. How to define Hugging Face. Like LangChain is like the framework to do RAG, but Hugging Face, they are everywhere, but nobody can really define what they do. Like OpenAI, they know you create models, AI models for you to use. Okay, Hugging Face is like, oh, I also want to get involved and also produce this model and also produce that model, but actually that not their own model. They will take for somebody else and repackage. It's more like a wrapper. But Hugging Face, to me, it causes confusion. Because, for example, sentence transformer, we know that it's open source. We know we can run it locally. But to install, we can install directly or we can install from Hugging Face. It's the same thing. It doesn't belong to Hugging Face, but you have Hugging Face version of sentence transformer. Okay? So sometimes some people say to me, oh, we need Hugging Face. I say, not all the time. Okay? Because if you can take it directly from source, you don't need Hugging Face. But when you use Hugging Face, sometimes you need Hugging Face API, sometimes you do not need Hugging Face API. So I'm just throwing out here so that you are familiar with Hugging Face. You have also Cohere embeddings, Vertex AI embeddings, Anthropics. You have this tag to image. This one is multimodal, OpenAI. So how to pick the best embeddings? Well, depend on quality versus cost. OpenAI embeddings are top quality, multilingual, and you need to pay, incur per request fees. But if you run locally, Sentence Transformer, the free and lightning fast, but less semantically rich. Okay, and you have this scale versus latency. If you want to have a low latency, high volume request, you can use local Hugging Face model, Hugging Face embeddings. But if you want to use for occasional to play around, you can use API model, OpenAI. If you want to deploy as a company, you want to deploy and you want to use OpenAI or Google using API, you need to really calculate the cost. The cost will shock you. It will run into thousands easily. Imagine you deploy an app, okay? Even though your user base is small, but if you don't control it, you can reach the API limit quickly. Okay. Right. Also depend on domain needs. If you need legal or medical, like a very specialized tax, you need to consider to fine tune local sentence transformer model. If for general chatbot, for like customer support, to understand your user guide, you can use like normal text embeddings or embed English. They can be used out of the box. You can also use hybrid embeddings where you combine local and also API. For this, you can use Hugging Face. If you install Hugging Face Sentence Transformer, you can use that Sentence Transformer locally, or if you want, you can also pay API fee to Hugging Face and it will run on the server. You can use image embedding DAL-E for multimodal RAG, and you can fine tune Sentence Transformer because it's open source. You can fine tune, but you need to understand the background. I mean, in terms of how they are set up. So if you want a free and local embeddings, Hugging Face embeddings here, well, basically Hugging Face embedding, they use Sentence Transformer as well. But if you use Hugging Face embeddings, you can use their API inference if you don't have GPUs. Remember that with very large tags, you need GPU. That's why in the demo here, we give very small tags. Okay, if you have a very large tag, because it's transformer model, you will need GPU. And you can use LangChain or any framework like a wrapper, LLM wrapper. You can use the original Sentence Transformer for pure local solution with minimal dependencies. And if you do research, okay, basically you prefer the specialized Sentence Transformer because you want to do you fine tuning, so you don't have to subscribe to any API fee, API license. Right. So if you decided that you want to use local, meaning running it on your own PC or server, and you decided it to be in, for example, in Malay language or Chinese language, you can use this multilingual Farapraise mini LM. There's a full list of sentence transformer embeddings. Okay, you can check. They even have the embeddings for scientific language. Okay, even though they are open source, I think that they are quite advanced actually. So you don't need to worry about using embeddings from the big names like Google or OpenAI. Right. So now let's talk about vector database. So vector database, how they do their indexing, search, and retrieval. First is they will take their query, and then they will use this algorithm called KNN, K nearest neighbor. So in machine learning or AI, this is very familiar, KNN. But in LLM, KNN is considered exact nearest neighbor because it will look for the exact word. Okay. So similarity is measured in terms of vector distance. So imagine a vector space. So if the vector is very closely related, okay, the distance very small. So either cosine distance or Euclidean distance. But KNN or exact nearest neighbor, it doesn't scale. If you require the exact keyword, when you have a very large text and very large query, too many query, they cannot scale, meaning it will run very slow. So it's better to get 10 approximately relevant results in seconds rather than one accurately relevant results that took hours to complete. So we use approximate nearest neighbor, ANN, not artificial neural network. So ANN here is approximate nearest neighbor. So there are two types of ANN, graph-based. Usually, the most popular within the graph-based is called hierarchical navigable small world, NSW. It will organize the vectors in terms of graph. So imagine the graph space, the vector space. Okay, you have points of vectors that are closely related together. They will slice and then make it into a graph. So graph, knowledge graph, usually you have node and also edges that connect between nodes. So the nodes will have some properties. The edges will contain how they relate, the properties or the topic. So here they use the graph to construct like a map for the vectors. Right. Each node represents a vector and the edge represents the distance. This is used in 5S. It was introduced in 2017. Another one, a slightly more advanced one, is tree quantization. So it will group nearby vectors. Okay, they will have a chunks of vectors. They group them together and compress them. Okay, why do we need to compression? Because remember, the vectors are stored actually in RAM. Okay, if you have limited RAM, so you cannot store very large vectors space. So you can compress. When you compress, you will have 4 times smaller memory and 8 times faster indexing and 4 times faster query. So this is used by Google Scalable Nearest Neighbors that was introduced in 2020. And you also have the hybrid ANN that store the centroid of cluster in memory, meaning in RAM, and list the vector in disk. So it will store in disk. Usually, the vector database, they do not store in disk because it will become slow to access. RAM is faster than disk. Okay, but RAM you have limitation in terms of size. Disk is bigger. RAM is limited. So hybrid ANN, they use both. Okay, to make it less memory demand. Okay, but still fast enough. So this method is used by ChromaDB. So if you use ChromaDB, they use this method span. But actually span was introduced by Microsoft in 2021. So in terms of the state of the art, I think span is the most advanced. Okay, most advanced meaning the most recent, not actually the most useful for every situation. So it depends on the situation. Right. I also want to introduce LangChain. LangChain is an open source Python framework. If you notice that in the example, usually we have code that usually start from embeddings. After embedding, it will store vectors, and after that, it will take query, it will generate prompt. That is what we call a pipeline. So if you use LangChain, LangChain will automate, not easily automate, but make it easier for you to build your pipeline by using LangChain. It can orchestrate the various steps in pipeline, prompting LLM, retrieving relevant context, and even you can manage conversation state, meaning you can remember the conversation, because in a conversation you ask too many questions. Sometimes the new question, with the new question, the LLM will forget the context of the conversation. It forgets the previous query that you gave. So to solve that, we can use this line chain to create a more responsive chatbot. So you can focus on your application logic rather than low-level boilerplate. So LangChain can help in the ingestion stage, which is offline. Use document loader to read PDF, web pages, text file. Can create embeddings via LangChain LLM wrapper. You also have the option to directly connect with any vector space of your choosing, Pinecone, Chroma, through a unified API. And it can also help during your runtime. You will wrap your vector database in retrieval object. Okay, it will create a separate object for your vector database. And from that object, you can have manipulation. Any object can be manipulated. So the retriever dot get relevant documents. You can fetch the top k chunks of relevant text. And during the generation, you can use a prompt template to combine the context with the query. It will pass the LLM wrapper to LLM change or retriever QA change. And using the same Python notebook, because you're using LangChain, you can easily change your LLM or any embedding provider with just a few lines. Okay, you can add agents if you need to model between multiple tools, and you can handle conversation context using memory. So in the startup scene, a lot of people are using LangChain. That's why I want to use LangChain. So it will allow for rapid prototyping. Will spin up right prototype in dozen lines of code. You have the modularity. You can easily swap models. It's very scalable. And you have a very active community. A lot of people using LangChain, and easy for you to get access for tutorials and demo. A lot of people are sharing LangChain based RAG notebooks. Right. So let's build our second RAG model. So we will take 3 Wikipedia articles for embeddings and indexing. So the 3 articles will be about AI, machine learning, and NLP. We will use OpenAI embeddings as the embedding model. So meaning that this one will require your API key, OpenAI API key. But the embeddings will be stored locally using FAIS, Facebook AI Similarity Search. We will retrieve and generate an augmented prompt based on simple user query. The query is, what are some ethical issues related to the usage of AI in education? So we'll use OpenAI GPT 3.5 Turbo as the LLM. Right, I will share the code, the collab code here. You can open, hopefully. Okay, please open that collab code. Right. Okay, for the first block of code, the line of code here, we install dependencies. Faiz, OpenAI, and you can see there, I use LangChain, document loaders, text splitters, embedding, vector stores, chat model, chat summarize. So when you use it like this, you can easily change the option here. For example, document loader, you can use different type of document loader. Okay, so later you just change the document loader instead of you need to import different packages or different tools. So now because we are using straight from LangChain, it's easy for us to change
like for example, text splitter. This one is using recursive character text splitter. Embeddings you can change from OpenAI to Gemini or whatever, because line change has can connect easily with a lot of different provider. This one use Faiz and chat model, chat OpenAI, and we use load summarize chain. Okay, here, set your OpenAI key. When you run this block of code, it will ask for API key. You enter your API key there. And then number 3, load 3 Wikipedia pages by title. So this loader, Wikipedia loader, and instead of giving links for the Wikipedia links, I just put in query. So this Wikipedia loader will search relevant articles containing artificial intelligence, machine learning, and natural language processing. Okay, and then the line below, docs equal loader load, will returns a list of document, page content, and metadata. Right, number 4, it will split long pages into 1,000, about around 1,000 token chunks with some overlap. We use this recursive character text splitter. So we define chunk size 1,000 and chunk overlap 200. So 1,000 is token. So chunk 1,000 token chunk size and overlap around 200 token overlap. We will allow for 200 token overlap. And then chunks is defined as splitter.split documents. Okay, number 5, we create embeddings and vector store. We use OpenAI embeddings. Okay, I would like to remind, OpenAI embeddings will require your API key. If not, you can use your own sentence transformer embeddings, and you can store that here. I'm using Faiz. This one is stored locally. If you're storing it in online provider, you need to have API key as well. Okay, number 6, we build a retriever for top K chunks. Okay, so this one is K3, so we'll take 3 chunks, top 3 chunks. And the summarization change, number 7, LLM chat OpenAI. Model name is the name of the LLM. This one temperature 0. Temperature 0 meaning it will strictly follow the chunks to give answers. Right. Summary change, we use chain type map reduce. Later we'll explain what does it mean by map reduce. And number 8, retrieve and summarize. Query what are some ethical issues related to the usage of AI in education. Okay, it will retrieve this. So these are the chunks that we retrieve. So remember that it will take a few articles from the Wikipedia containing the topics of artificial intelligence, machine learning, and natural language processing. So this one is I asked it to print the chunks. So this is the example of chunks that they chose. Okay. Obviously, it's not the end, so there's still more. I only picked a few. And after that, number 9, finally, we build prompt and call LLM. So if this one, the prompt context, we join the chunks, okay, the 3 chunks and the context for the context, and then we start the prompt with the "you are helpful assistant," takes this content, take this prompt context, and then answer this query. So that is the AI answer. Some ethical issues related to the usage of AI includes 1, privacy concerns, and number 2, bias discrimination, and etc. You can play around with this code by changing the temperature. You can see different AI response. Okay, hopefully you can follow that. But obviously, when you running this, you need the API key. So if you don't have API key, you cannot run. Okay. So I stop here first for a question before I go to the final example. Okay, so let me see some question first and answer them before we continue with the third one. Right. Right. Okay. Is it free to use the Open AI API? No, but cost will be minimal. Just put the minimum $10 USD, and then you can run the code that I shown here. No problem. You will not even spend $1 from that. It will stay there. The $10 will stay like even years if you don't use it. It will not expire. Right. Is launching word with multi-language? Yes. Open Router has a few free hosted model. You can try it out. Grok also. Okay. I have seen one AI ML API. AI ML API. They call it AIM-LAPI. AI ML meaning AI, artificial intelligence, ML, machine learning, API. So I think you just pay once, they give you a lot of API keys. I think that's the concept lah. It's like for example, Netflix. For example, you pay for a subscription Netflix, and give you a lot of shows. I think that's their business model. So, I mean, obviously you need a lot of API key to test from OpenAI, Google, DeepSeek, kan. So you need to subscribe for all, kan. So better just use that one and then pay once, and then you get a lot of API key. Yeah, I never used it before. I've seen it. People talk about it in forums. Okay. Okay. Is it possible if I use Gemini API and pip install? Yes. Okay. Under which use case we need to use RAG? You can refer to the slide. Later we'll give the slide in the first part. Right. So I think we can continue with the the third demo. Okay. Up until now, we have done one demo for RAG, simple RAG model without lane change and simple setup for summarization. Okay, and this one also for summarization. We take a few articles, we summarize, and basically we give one question only. But what if we want to have multiple Q&A kind of rack? So that is the example. Our third rack model, we will take a short article about drug interactions for embeddings and indexing. So we will still use OpenAI embeddings. We will still store it in locally using Faiz. We use different chain type. Before this, we used this chain type, MapReduce. We will change it to something else because MapReduce is not suitable for rapid question and answer session. You can input 3 questions about the article, and we use OpenAI GPT 3.5 as the LLM. Right, so let me include this link in the chat so that you can run it as well. Okay. Hopefully you can open the Python notebook in Colab. So first we install dependencies. Okay, we use length change. So typically these are the workflow. We start with document loader, text splitter, embedding, vector store, chat model, change. And after that, we set in for it to have API key. This one is for OpenAI. And we prepare our knowledge base. Okay, here, because we want to make a quick demo, we put in this text here, small text. So this small text contain information about a few interaction of common drugs like aspirin and ibuprofen, warfarin, metformin, ACE inhibitors. So imagine this like a user guide. You work for a health company. You want to take user guide. If you use this drug, do not use it with this drug. Okay, the user guide will be quite long. Okay, the demo is quite small. So we'll split the text into chunks. Okay, chunk size 500. Okay, for Q&A rack, we do not put in a very large chunk size. That is like a rule of thumb. It's not, you don't have always to follow that. You are free to also use larger chunk size, but usually we put it small. And the chunk overlap is only 50. Okay. And then we embed an index. We use embeddings, OpenAI embeddings. This will require your API key. And then we store it in the FAIS. This one is stored locally. And after that, we build a retrieval QA change. Okay. So the LLM we set and we give temperature 0 because we want the answer to only follow our text, not follow something else. And then we use here, see, chain type stuff. Before, in the previous example, we used chain type map reduce. For this one, we use chain type stuff. Okay, I will explain later the difference. Chain type stuff is more suitable for Q&A. Okay, but we still take k equal to 3. So I remember just now somebody asked about the value of k, top 3 or top 5. I've seen a lot of example people use 3 only because you need to understand the context window. If you use 5 and your chunk is big, 1000 token, and you take 5k, 5 top chunk, meaning 5000 token. Your contact window is how big is it? Okay. And we ask 3 questions here. Can I take aspirin and ibuprofen at the same time? What should I do if I have to get a CT scan while on metformin? And is it safe to drink grapefruit juice with my statin? Okay, and then we'll answer for every question. Okay, so this is the answer. Can I take aspirin and ibuprofen at the same time? So this is the answer it generates. It generally not recommended to take aspirin and ibuprofen at the same time because ibuprofen can reduce aspirin cardioprotective effects. Okay, and notice that at the end it says here it's best to consult with a healthcare provider before combining these medications. The last sentence it gave, that one comes from its own response, not from the chunk. You see, it's best to consult with a healthcare provider before combining this medication. If you notice in the original text, there's no such thing. Okay, so basically you can imagine this is like the personality of the LLM itself. And this personality is hard-coded by OpenAI. So OpenAI, because they are ethical AI, they want to be considered as ethical AI provider. So it has this condition settings that every time people ask for general health question, it will include this kind of message. But this one is not actually, it doesn't come from your text. Okay. But everything else comes from the text. For example, here, the cardioprotective effect, it comes from the text. Okay. The second question, what should I do if I have to get a CT scan while on metformin? And it answers, if you have to get a CT scan, it's important to follow recommendation to hold metformin for 48 hours before and after the imaging procedure. This is to reduce the risk of developing lactic acidosis. And again, the final sentence says, make sure to consult with your healthcare provider. Okay, this is the personality of the LLM itself, which is hard-coded by the developer. But everything else should come from the original text. Metformin, risk of lactic acidosis. 48 hours before after imaging. Okay. Right. The final question: is it safe to drink grapefruit juice with statin? And the answer: no, it is not safe to drink grapefruit juice with your statin medication. It can inhibit statin metabolism, raise statin level, increase side effect. And again, it ends the answer by saying, oh, it doesn't give any advice here. Consult your healthcare provider. You stop there. Right. But the answer is actually grounded by the stats. Grapefruit juice inhibit statin metabolism. Right. Okay, so now I want to explain the difference between chain type. So before, for the summarization or for simple question, one question and not a rapid Q&A question, you can use MapReduce. MapReduce is actually, you will have two steps. The first step is map step. You will split your retrieve chunk into groups. And then it will run the LLM per chunk. Okay. Here will cost you a lot because for every chunk, it will fit into the LLM. So one LLM query requiring you have two API key and they will incur costs. And from there, the LLM will give summarization. So imagine you have three chunks, it will fit into the LLM 3 times. Okay, read this. You will say to the LLM, read this, and read this, and read this, and give summary. And from that summary, it will reduce into a prompt, a final prompt. So basically, with 3 chunks, you will have in total 4 times interacting with your large language model, 4 times. Each for each interaction first for the each chunk, and then after that the final prompt. Why do you use MapReduce? You want to use MapReduce when you have a very large chunk. Okay, so you will reduce the chunk into summarized statement. And that summarized statement can be included into your final prompt. So it will scale to large number of chunks, then you will never exceed the context window. Okay, by summarizing each chunk first, you force the LLM to focus your piece in isolation. It will yield more accurate, well-organized final answer when you have lots of data. The cons, higher latency and cost. In this last example here, we run 4 LLM call. Okay, because we have 3 chunks. So we have 3 LLM call for each chunk, and then the final prompt. And if the intermediate summaries are poor, the final reduced map cannot fully recover. Okay, so they will propagate error. And they are slightly more complex to debug. Okay, when you have an unexpected answer, final answer, then it's hard for you to pinpoint at which point you have problems. If you use chain type stuff, it will simply concatenate. It will combine everything into one big prompt. Okay, it will stuff everything, force to the LLM. So take all this document, no matter how big is it. But remember, our chunk is only 500 token. Because we have small chunks, it's okay. But if you simply fit into it, we have, for example, we set 1,000 token per chunk, so we fit 3,000 token into that one large prompt. So it's going to be too much for the LLM. It's simple and fast. Only one LLM call. Okay, but it can hit the model context window limit if you have very large chunk, and it can overwhelm the LLM with too much context. Okay, and more prone to hallucination if irrelevant chunk sneak in. So remember the vector search, they use approximate nearest neighbor. Because it's approximate, it's not exact. Some irrelevant chunk could sneak in. Okay, so that's why we use small number of top chosen chunk, basically 3. Let's say if we choose 5 or 10. So irrelevant chunk could be included as well. If you only select top 3, lower chance for it to select irrelevant chunks. Okay. Right. Maybe I open for more question first before I continue a little bit. So let's see some question. For case, if one document we insert into one rect table, what if we have multiple document? It's easy for you to set to read multiple document in the document loader. This one I shown only using either Wikipedia loader or the text that we created ourselves. But it's easy for you to just change a few keywords for it to read PDF document, for example, in your big folder. You have maybe 100 documents there. No problem. If use the staff method, how to solve the cons of hallucination for Q&A tasks? Basically using a smaller chunk size, 500 token. Do not use big chunks. Use small number for K. Maybe usually we use 3, but if you want to make it strictly selecting only relevant, maybe 2 even. And then we set low temperature. Okay, just now we set 0 temperature. Do not use more than 0.3. Okay, that is not science. That is basically like rule of thumb, advice. Okay, don't ask me where this number come from, 0.3, 0.2. Okay, this is what I seen people do. Okay, so let's proceed to the final topic. Right, we have seen how to build RAG pipeline using code, Python notebooks. So if you're interested in building startups, you want to offer SaaS, okay, software as a service, to make money, I think it's faster for you to use this GUI based than using code. The code one, if you're doing research, like for example, like I said before, you want to build an app to understand Malaysian legal documents. Okay, that require a lot of documents, a lot of in terms of human, human coding hours for that. So you can use code. But if you want to offer to SMEs, I can build, for example, you say I can build agentic AI chatbot for you that can answer question about your products or your user guide or whatever. I think it's easy for you to use this using GUI. And I would like to recommend this one, the easiest one that I found, n8n.io. Probably you already familiar. Yeah. So this one, I just take straight away from the template. The template is already there. This one to build a rack system for chatbot using WhatsApp. Okay. So, for example, this one is to use the brochure, Yamaha product brochure, and then you have that component, extract from file, and store it in your vector database. Okay. This one is using, you see, still using the example that we use in our code, recursive character text splitter, and that one embeddings OpenAI. You can change to different embeddings and the type of text splitter. And from there, you can set up with your WhatsApp, okay, to handle message type. If you are, if the AI doesn't understand the question, it will reply something else, something. And if it understand the question, it will go through the stored vector and to retrieve and then understand the product catalog and give an answer. This is very quick to build, less than 1 day, even less than half an hour. So it depends on the kind of service that you want to offer. Okay, for myself, because I'm in academia, and also for my startup, we are using it for drug design. I prefer code base. Okay, But if you are in, this AI, you want to build a startup, you want to offer this as AI service, use this. Okay, and there's thousands of example in N8N. Yeah, I cannot even catch up. They use an automatic system that can create videos, Google View, the one that can extract videos or text or whatever from YouTube. A lot of things. You can maybe worthwhile for you to explore this. Okay, and so in summary and conclusion, RAG is a very powerful method to customize your pre-trained LLM to understand new text or documents that has been not trained on. But there are too many LLM tools, library, frameworks to choose from. Okay, that will give you headaches and confusion. There are also too many embeddings and vector database to choose from. And again, I will say this: if you're doing research or academic, better to use code base. And if you are in commercial, you want to offer service quickly, GUI base. In the recent opinion, people within this field, they say RAG might be made obsolete soon with the advent of agentic AI. So you can set AI agent to do everything like we did in the code, RAG, they do it for you instead of you coding it yourself. Okay. Right. So that's the end of my presentation. So yeah. You want to?
Yes, sir.
Hello, can you guys hear me? Thank you, Dr. Azam, for the very informative session. And before we end this session today, we would like to have a photo shoot session first. So we'll do it for the physical one first, whoever's at the session physically. And then after that, we'll do the online photo shoot as well. All right. All right, now we'll do the photo shoot session for the online one as well. So we also enable the camera for those who wants to on their camera and show their face as well for the screenshot. So once everybody is ready, we will start. You can join also, yeah. Wait, I need a set background first. Wait. You can see it. Change voice.
Sorry.
Yeah, I can see it.
Okay, I think I will take the screenshot.
Yep.
Maybe give it 1 or 2 more, 2 or 3 more seconds
Give it
if
2 or
anyone
3 more
else wants
seconds,
to
yeah.
join.
Once everybody's ready.
Okay, right. Everyone can just hold the smiley faces.
Okay.
Yeah.
Okay, everyone, I'll just screenshot now. Lah.
Mm.
Okay, smile everyone. Okay. Right, so all the screenshots been taken. Can.
Okay. Thank you everybody for joining the online and also physical as well. Thank you for spending your time to listen to Dr. Azam's speech as well. Very informative session. Thank you everybody for participating as well. See you guys for week 3. And also week 3 is already posted up. You guys can check the Luma as well. So do remember to get your tickets for the week 3 session for both online and physical as well. Thank you guys for joining.
Thank you.